Okay, yep, so 7E, now in our textbook, 7E is split into three components, E1, 2 and 3. Today we're going to do E1 and E2, alright, because 7E3 is a bit harder, there's a fair bit more algebra involved. Today it's a bit of looking at graphs and using our calculators. So we'll do both to start. So 7E.1 is solving graphically, and you're going to be given some graphs like this, like the one I've presented up here. Consider the graph, and it says find x such that cos of x equals 0.8. Alright, so you can see these y values are the cos of x values, right? All these y values, and we want to know what's the x value when the y value is 0.8. So this is an estimate, it's an approximation, right? So if here's 0, here's 1, here's 0.8. 0.8 is like here, all right? That's maybe up a little bit, I'll go up a little bit higher. There's 0.8, and so we're saying, what's the x values when the y value is 0.8? So it's going to be there, 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 and it's going to be there. All right, so I've just drawn a line across. That's where it happens. And then, you know what? What's the x values that correspond with those points? And you just sort of have a guess. The first one's going to be like 0.6. So because we're estimating, it's going to be pretty rough going. Here, that's like 5.4. And we just list all the solutions. 5.4, that's pretty close to 7. I'll say 7.1. You'll have your ruler, you'll be able to do a bit nicer. That's maybe 11.8 or 9. And 13.3. All right, so if I go to all of those x values, all right, let's just pick one. Let's go for x is 7.1. That's about here. What's the y value of the function? 0.8. That's what we're saying, okay? It's saying find the x values such that the y value, the cos of x value, is 0.8. Okay, now, that is correct, except it says find the solutions from 3 to 13. So there's one thing we need to consider here, and that is the constraints, all right? Our solutions must occur between 3 and 13. One of these solutions is not, two of these solutions are not in that domain. Okay, that's going to be the first one because that's less than 3. So we reject that because it's outside the domain. Rejected. And the same with this one. This is just too large. All right, 13 is inside the domain, but anything larger than 13 is outside the domain. So between 3 and 13, these are our only solutions. Okay? So just looking at the graph and approximating the solutions there. All right, now remember we're dealing with the function y equals cos of x. Okay, that's the function. And so when it says y equals cos of x, find cos of 4, well that means x is 4, right? See, if we've got y equals cos of x, find cos of 4, it goes, when x is 4, what's the cos of x value? So we'll go back up to our graph and we'll go, yep, x is 4, that's where x is 4. What's the y value? Here it is. What's the y value come across? It's like minus 0.6. So cos of 4 equals minus 0.6. Okay, so we're just guessing as best as we can, using your ruler, approximating, familiarising yourself with the graph and so forth. Okay, so that's 7E.1. Don't spend too long on it. Don't spend too long fussing over what the correct solution is and so forth. All right, let's move on to 7E.2 then, which is where we're going to solve using our graph mode of our calculator. So pull your calculators out, and this is an opportunity for us to recap how we can use technology properly. So, there's a couple of ways of doing it. I think what I might do is, rather than using Desmos, I'll use the emulator. Calculator, emulator, what's it called? Emulator. calculator. It's the CG50. No, it's yeah. All right, so in graph. Okay, so I'm going to show you, let's look at the first one. We have sine x equals 0.542. Sine x, we're going to graph it. And we're asked to graph it. We're told find solutions between 0 and 3 pi, right? 0 less than x less than 3 pi. So that means our v window, we go from x is 0 to x is 3 pi. Now, because our domain is in terms of pi, that means our calculator needs to be set in radians, right? So we make sure our calculator is in radians. So I'm going to press enter and I'll show you how we do that. Firstly, shift menu brings up where we can change it to radians. Okay, you can see mine says angle, rad, sorted. Okay, next we need to change the V window. So I'm going shift V window and I'm asked to graph it from 0 to 3 pi. Done. And I'd already seen the y values and I'd already seen that y was okay, like I didn't really need to change it. All right, another way to think about it, if you have the y equals sine of x function, okay, the amplitude is 1, right? So that means it's going up 1 and down 1. So you can set your y from -1 to 1. Okay, now we are asked, find the x values such that the y value, such that sine of x equals 0.542. Okay, so let's show you two procedures we can do. The first is to g-solve, all right, which is F5, g-solve, all right, and this brings up lots of options, doesn't it? G-solve, and we can see we've got, find the roots, that's where it crosses the x-axis, find the maximum points, it'll tell you the coordinates there, find the minimum points, tell me the y-intercept. Tell me where it intersects. That's where it intersects another function. We'll look at that in a moment. We're going to press the across arrow because there's more options. What are we asked to do? Find x. So we should do a x calc. We want to know an x value. Find x. We do an x calc. Given the y value is, well, what's it equal to? 0.542. All right. So our first answer. So this is question A, sine x equals 0.542. So we've got x is, here's our first answer, 0.5728. So we write 4 figures and then round. What I might do is write them here like this, 0.573. Okay, that's the first solution. We need to get the next solution. All right, and so we press the across arrow on our keypad, and it's going to move across to there, because there, it also equals 0.542. All right, press the across arrow. The next solution, 2.568. All right, the third solution, 6.856. And the fourth solution, 8.851. So always writing 4 numbers and then rounding accordingly, rounding to 3 figures. Now, we don't need to consider the domain here because we restricted our V window. That means all of the solutions are definitely in the domain because we restricted it right at the start. So that's part A, right? Let's show you another way of doing it quickly. All right, so you can g-solve and do an x-calc. Another way, what we're asked to do is we're asked to find the solutions to sine of x equals 0.542. So we can sketch sine x, like we've got, and then we can sketch the function 0.542. It's going to be a horizontal line at 0.542. I'm going to sketch both. And so you can see, here's the x-axis, here's the line, y equals 0.542. And then we can g-solve. intersection, ISCT. And it's going to tell you the coordinates where they intersect. It tells you the coordinates where this function equals this function. We got the first one, 0.573. All right, and you can just use the across arrow to bring up the same solutions. So just an alternative procedure that you can use. All right, hop out. Let's move on to question B. We have 3 cos 2x plus 1. All right, 3 cos 2x plus 1. All right, now we're asked to find where it equals 0. So we could type in here 0 and g-solve the points of intersection. All right, that's a good way of doing it. Maybe we'll do that. All right, why can't we see the second function? Y equals 0 is the x-axis, isn't it? If y equals 0, it's a horizontal line drawn right there. And so let's just g-solve the points of intersection. And so it's going to bring them up. They're the solutions, right? And we can write all of those solutions down. So first one, 0.9553. All right, so we have, what's it? 3 cos 2x plus 1. And we've got x equals, first one, 0.9553. All right, I won't list all of them because it gets a bit monotonous going through just listing the same answers, right? Okay, so you go through, find the solutions. I'm just going to put plus more. Again, because we've considered the domain, all of those are appropriate solutions. So that's one way, okay? That's probably the easiest way, isn't it? Graph the left side, graph the right side, g-solve intersection. Just quickly as well, let's point out a connection though. If we're finding when it equals 0, we're finding the x-intercepts. What are the x-intercepts? They're the roots. So if you were to g-solve the roots of this function, they're going to be the same. Okay, g-solve the roots, they're the same. All right, so that's another good way, a good connection to make, a good way to think about it. And lastly, okay, is the very first procedure I taught you, g-solve, xcalc. We want to know the x values when y is, what's the right hand side say? 0. And so we can go through. So there's 3 ways of doing it right when you're asked to find it equal to 0. Okay, last one. We have cos x equals 2 sine 2x. The only way to do this one, now there are 2, but I'm just going to say when you're given 2 functions like this, let's not complicate it. We're just going to graph both functions and g-solve the points of intersection. So we've got cos x and we've got 2 sine 2x. All right, so I'm graphing both of those functions and then I'm going g-solve intersection. And then every point of intersection, you can see there's quite a few, intersects here, 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 here. So I'm going to list all of those. So this is when cos x equals 2 sine 2x, x equals, and we'll go through 0.2526, 253, press the across arrow, it's going to bring up the next point of intersection. All right, 1.57. That's pi on 2. You can start to recognise them, 1.570. But we're just writing it to 3 significant figures. Really good. So that's enough to get through 7E.1 and 7E.2. That's where we're going to dedicate our time today.